I have a little video on chapter 2.3, quadratic inverses. It's kind of hard to see, I know, with restrictions. So the first thing we have to do is look at over here is what the question says. It'll tell us, hey, given the f of x, find the inverse function, graph each simultaneously. So we have an f of x. We're going to find the inverse. We're going to graph both and state the domain and range for each. All right, so here's our function. F of x is equal to the square root of x plus 3. In order to graph it, what we want to do is first figure out, well, where do we know our x's might be restricted? So anytime we have a root function or a radical function, we have to set the inside equal to 0 or use an inequality greater than or equal to 0. And we solve for what that x value is. In this case, we get x's must be greater or equal to negative 3. So from there, we can build a simple xy chart. We have negative 3, 0. If I plug in a 1, 1 plus 3, square root of 4 is 2. And the next great number that's square rootable or a perfect square would be 6 plus 3 is 9. Square root of 9 is 3. We look at the domain. Domain, x is an element from negative 3 to infinity. That's basically what we described here. Okay? And then we can take the range. The range is the y values. Y is an element of including 0, because 0 is a value, to positive infinity. All right? So now, we have found the basic points of the graph. We have found the domain and range. So now what we have to do is go find the inverse. All right, let's walk over here, and we're going to now find the inverse. All right, here it is. So we can see. I can hopefully get there, and you can see it. It says y is the square root of x plus 3. We're going to switch our x and y's. Okay, switch the x and y's. So we get x is equal to the square root of y plus 3. And then we end up with, once we do that, we square both sides. So switch your x and y's, then square both sides. You'll get x squared is equal to y plus 3. I subtract 3 from both sides. And so this function I decided to write in green, so we can decipher the two. And we get x squared minus 3 is equal to the f inverse of x. We plot a few points. We build a small table. We find that if we put 0 in for x, we get negative 3. If I put 1 or negative 1, it is negative 2. And if I put 2 or negative 2 in there, we get 1. Now, when we do the domain and range for this function, you'll notice that we get x is an element of basically all real numbers. Well, negative infinity to positive infinity. Sorry about that. So I hope you can read that. It says, and range is from negative 3 to infinity. Now, in an inverse function, these values should match, right? What should match is the domain becomes the range, and the range becomes the domain. So let's look and see if we've accomplished at least that so far. Again, we'll go back over here. Let's start with our initial function. We notice that our domain is x is an element of negative 3 to infinity. All right. Does that follow with our new range? Y is an element of negative 3 to infinity. So what we can do is we can put a check mark saying yes, those two are good. Okay? Now the other thing that we have to do is look at the domains. The domain, the range over here should be the domain over here. But in fact, we have a domain issue because we have it from negative infinity to infinity. Well, and that's, if we look at the graph, you can see that this parabola, now I've only drawn half of it. The other half would go to the other side, which would be at 2, 1, and then at negative 3, 6. And so this parabola basically would also come down through here. Now the reason I didn't draw that side is because of the fact that it has to be an inverse function. As soon as I draw this, I may pass the vertical line test, but remember, an inverse function has to pass not only the horizontal line test, but it also must be 1-to-1. And you'll notice that as soon as I graph the other side of this parabola, I no longer pass the horizontal line test, and therefore I am not a 1-to-1 function, nor an inverse. So, what do we have to do? We have to restrict the domain. So let's go back over here for a second. Follow me. And we can now start to restrict our domain. We want our domain to only be from the positive side of our x values, right? And so because our range over here, let's go back over really quick and see the range. The range said it's from 0 to infinity, so that's what our domain should be. So we're going to put domain, we're going to write the word restricted. Okay, we write the word restricted, and we're going to put the domain is x is an element of including 0 to infinity. And we like that word restricted because that tells us that, hey, we've taken a parabola or a quadratic function and we've restricted the domain to make sure that we meet the requirements of the inverse function. So we can actually now go back and get rid of that because we don't want it. And we should notice that when we graph this, it will not only intersect at the y equal x axis, but now it's a 1-to-1 function. It passes the horizontal vertical line test as well, and it also reflects about the y equal x axis. And at this special point right here, this point of intersection, what we would notice is that the x and the y are the same. Again, y equal x. So that is a very specific point, and we want to make sure that we have that. If it intersects, they all don't intersect, as we've noticed in class. Anyway, have a great day. Hope this helps. Talk to you soon.